Alrighty, in this video what we're going to do is we are going to start working on the implementation of our server-side API for working with our systems. There's a couple of things that I decided to do slightly differently. It's not going to require a whole lot of changes. They're mostly just going to be additions. We're going to have to add a new class that I'm going to put together for writing out our events, as well as put together a new property on our server context. And I'm also going to remove some redundancy, like we have this server context application being passed into the client systems constructor, but we can navigate to that through the client context itself. There's no need to have this in there. But we're not going to be working on the client systems class just yet. The first thing I want to do is I want to add the new class, and I'm going to go ahead and call it an event writer. And so what the purpose of the event writer is the first way I was planning on doing this was to create a class per event and simply have a static method on each one of those classes. I think that might be a bit of a waste of space, and I think it'll be a little bit nicer to have everything consolidated if, for whatever reason, we decide to write our events differently in the future. So what I'm going to do is I'm going to take out the event namespace, or the events namespace. Now, note that I'm not deleting the event class. We're still going to be using this class to encapsulate all the information that event needs to execute. But what I'm going to do is I'm going to go ahead and add a new class, and I'm going to call it an event writer. And so the responsibility of this class is simply to take the concepts of what events we want to write and actually write out the dictionaries for them. So the event writer is going to actually need a reference to a serializer because it needs to know how to serialize event arguments. Because remember, this class is going to be responsible for things like, oh, we want to tell the client that a method was invoked on a system. This class is going to take that concept and package it into an event object. So I'm going to go ahead and put in a constructor here, and I'm going to go ahead and have a iSerializer, which if I can remember how to, there we go. And we'll call this serializer. So I just imported in the base infrastructure namespace, and I created the constructor parameter and assigned it to a local variable. So I'm not going to worry about implementing these methods quite yet. I'll leave them unimplemented, and I'll probably end up implementing these things last. But we do need to put in some method stubs here in order to actually go ahead and implement the rest of the system. So the things that we need to do is, at the moment, we're not working with actors. We're not worrying about actors at all. We're just worrying about the bidirectional RPC framework. And that's just going to require 3 types of events to be sent to the client. So we'll need a public event, and then we'll need a add system. And the add system method, let's have it taken a registered system. And then we'll throw a new not implemented exception. So of course that brought in using system at the top. So the add system method will generate an event for adding a system to the client to tell it that it needs to create a login system or a character select screen system or an inventory system or something like that. We'll also need a public event remove system, which I'll have taken a registered system, and he'll throw a new not implemented exception as well. Then we need a way to actually invoke the methods on the systems we've created. So I'm going to say public event invoke method on system. And in this case, I'm going to take a registered system to know which system we need to invoke that on. Alternatively, we could take in an ID directly here. That would maybe speed things up just a tad. Yeah, I'm going to go ahead and take in an ID here. I'm going to say go ahead and take in a byte client interface component ID. So that'll be the byte that represents the interface component ID on the client. In addition, it's also going to need to know what method was invoked. So we're going to take in a method info. Or we could just take a mapped method and do method. And then, of course, we'll also need our object array of arguments. So with these three parameters, we have enough information to tell the client what needs to be invoked. I'm taking in a map method instead of an ID or something because we should be able to get that information fairly easily. It also plays into something I was thinking about doing with more dynamic code compilation in the future, where we don't rely on the Castle dynamic proxy. So anyway, so we have these three methods. There's another event that we do need to be able to send to the client, and that is when the client gets created, it needs to know information about the component maps in particular, and potentially other information as well. So at the top here, I'm going to say public event, and I'm going to go ahead and call this, I'm going to say player init event. And it's going to take in a server context application. So what this event is going to do is it's going to simply serialize down the component maps. And we'll only have to invoke this once, fortunately, because we can just reuse the same serialized event for all the clients that get logged in, because the component maps aren't going to change during execution. Alright, so we now have our event writer, at least a stub for it. So let's go ahead and jump down to our server context and talk about some of the things we're going to have to throw in here. First of all, I don't think we'll have to worry about... I think we will, actually. So I'm going to go ahead and add in two new properties here. I'm going to say public iSerializer, because we'll need a serializer that's globally accessible within the application so that our peers can deserialize the requests that were sent in. And we also need an event writer, and I'm just going to call this property events. All right, the next thing is I'm just going to add some spacing here, maybe something like that. Just make it a little nicer there. Okay, so the next thing is we need to talk about the server context. I think that's going to be the first component that we implement, because it is going to be kind of the backbone of the entire application. It contains things like our component maps, our type registries, our IOC container, our serializer, and our events. And it's going to need a couple of responsibilities. First of all, we need some way to create the container, the IOC container. So we need some way to register some types. Now, it's possible that our BuzzMMO server master and server region are actually going to have a different set of components that they might want to make the client aware of. And so therefore, I don't really want to do my IOC configuration inside of this project, because also in addition to that, our server master and our server region will have the component classes inside of them. So they need a way to register themselves with that. And they also need a way to scan the assemblies for the different component maps. So what I'm going to do is I'm actually going to go ahead and make the server context class abstract. I mean, those of you who have seen some of the other code that I've written, I'm not a big fan of abstract classes and inheritance, but I think in this particular case it makes a little bit of sense. For now, I'm going to keep the server context relatively simple and straightforward, but in the future we're going to add some interesting stuff to it. So basically, what we need to do is we need a way for the server context to get some required data. Also, I'm going to make its constructor protected as well. So the data that the server context needs to have is it needs to have our serializer, and I think that's about it. See, what I'm going to do here is I'm going to say iSerializer, serializer. That's the one thing that is going to be simply passed into the constructor. Then what I'm going to do is I'm going to remove the throw new not implemented exception, and I'm going to go ahead and instantiate our player system component map and our actors component map. I'm also going to instantiate our system type registry, and I'm going to go ahead and instantiate or set our serializer to our serializer, and then instantiate our events to a new event writer, passing in our serializer. So what I want to do now is I want to go ahead and write a protected abstract method, and it'll be called configure, and it'll take in an a container builder, which will be used to do all the IOC stuff. Then what I'm going to do is I'm going to invoke the abstract configure method from within the constructor, the server context. And I'm going to say var builder equals new container builder. And then I'm going to pass in builder into the configure method. Then I'm going to say container equals builder.build. So this will give us an opportunity to register some components inside of this assembly. And then when we inherit from the server context in our BuzzMMO server region and our server master, we can provide our own implementation. So our server context is actually going to change responsibilities, whether it's in the server master or server region, but since we're not worrying about load balancing quite at this moment, we can just leave it as it is. But bear in mind, we're going to go back and kind of rip apart this class later. If you have ReSharper installed, you'll also notice a virtual member call and constructor warning. What that's telling you is having a constructor call virtual methods is actually considered to be bad practice. And the reason it's considered to be bad practice is because the field initialization happens in the opposite direction of constructor initialization or constructor invocation. And what that means is, although the server context constructor will be invoked first, the field initializers of whatever inherits from server context won't be invoked until all the constructors are done. Now, fortunately, I hate field initializers, and you don't have to worry about me using them, because if I did, we could run into some nasty bugs. But in here, I think the design of how the server context is set up outweighs that potential issue. So anyway, so now that we have the server context done, the configure method also will allow us to configure our player's system component map, our actor's component map, and our system type registry, so that we can have all of that, that information ready. And then I guess I can go ahead and also add another property to our server context, and this will be public event player init event. So this will be the cached event that is sent to every single player that gets created. And then at the end of this constructor, I'm going to say player init event equals events dot player init event, passing in the server context. There's one more thing I don't like about this, and that is for some reason I gave this method an event suffix, whereas I didn't add a suffix on any of those. So I'm just going to go ahead and call this player init and rename it. You could alternatively go ahead and rename each one of these methods to something like create player init event and create add system event too. Usually you want your method names to have verbs in them, but I'm going to break that rule too because I think this will look nicer. Alright, so now that we have that all done, we can move on to, let's see, our client context, because I think that's all we need to do. So let's move on to our client context, and let's work on this. Now the client context is going to be interesting because the systems available for one client might not be the systems available for another client. So what I mean by that is you might need to pass in a different component map for the available systems depending on what client was instantiated. So what I'm going to do here is in its constructor, I'm going to take in a server context. First of all, we need that. Then I'm going to take in a component map, systems component map. And then I'm going to take in a iServer transport. And those are the three parameters here. So then what I'm going to say is application equals application. I'm going to say systems equals new client systems, and I'm just going to pass in this. Yes, I know the constructor currently takes in a client context and a server context, but like I said, we're going to be removing that second parameter later. So I'm just going to pass in this as the parameter. The client scope is going to be set to application.container.beginLifetimeScope. And I guess I can also go ahead and pass in this as the tag to it, a reference to the client context. After that, we need to set our component map. So I'll say systems component map equals systems.component map. This property doesn't exist yet, so be very, very careful. Make sure that you're setting it to capital S, systems component map, because we're going to be creating this property here momentarily. So make sure that this is an error, or this line errors out first, so that you don't say systems component map equals systems component map when you're assigning the parameter to itself, which would be bad. Then I'm going to say transport equals transport. Okay, so let's go ahead and create our systems component map property. I'm going to say public component map systems component map. And that should be that. So again, the client context is really just kind of a bag that describes the client that we're currently working against. And again, we use this information to add convenience properties to our client, like our player context, which inherits from client context, will have reference to like what zone he's in or what avatar he has and all that fun stuff. Okay, so on operation request. Like I said in the last video, the on operation request is going to, by default, simply invoke method on system. So I'm going to simply pass in evoke method on system. I'm going to cast code to a byte, and I'm going to pass in parameters. And again, that's because by default, all of the communication between the client and the server, with the exception of the initial handshake, is going to be done through the system's RPC framework. However, there might be times in the future where we might want to make some operations that that aren't invocations of a system. Like if we wanted to create a something that might have different performance constraints, for example. So I don't want to lose the flexibility of being able to have a custom operation code. But for now, we're going to treat all operation codes as invoking on a system. But in the future, we could override this method to add additional behavior, and then if it's not an operation, a special operation, then we just pass it back into the invoke method on system. Now, invoke method on system is going to be fairly interesting. So we need to get the server interface component or system by the server interface component ID, and we'll also need to extract the method ID from the parameters as well as the additional parameters. Then we need to retrieve the system object and invoke that method. So what we need to do is let's see here. So what we need to do is first get our mapped component. So we first need to get the server interface component equal, which is going to equal systems component map dot get component, or sorry, dot components at server interface component ID. So this will give us the information about all the methods that can be evoked on it. Now we need to get our method ID. So I'm going to say method ID equals cast to byte parameters at cast to byte operation parameter dot method ID. So remember our operation parameter enum. We're going to add a method ID attribute or enum member to him here very shortly. And now we need to extract our parameters, and we need to deserialize them. To do that, we need information about the method. So I'm going to say var method equals server interface component dot methods at method ID. So this will give us information about that particular method. Now, you might be noticing I'm glossing over the ability to return data. We're going to do that later once we see everything working. I just want to get the bare minimum so that we can see some communication happening. Okay, so now that we have the method extracted, we now need to get our parameters, or our arguments. So I'm going to say var arguments bytes, or yeah, argument bytes equals cast to byte array parameters cast to byte operation parameter arguments. So that'll get the serialized byte array out of it. Now we need to actually get our arguments. So I'm going to say var arguments equals application.serializer.read arguments. And then I'm going to pass in I need to pass in a binary reader, don't I? So we need to go ahead and say var using ms equals new memory stream, using var br equals new binary, or ms equals new memory stream, passing in argument bytes, of course. And then we need to do a binary reader passing in the memory stream, and then we can extract our arguments. Of course, since we're opening up in a different scope, I'm going to need to declare the arguments array outside of the scope. So I'm going to do that right here above these using statements. I'm going to say object array arguments, and I'm not going to assign it to anything. Then I'm going to say arguments equals or application dot serializer dot read arguments, passing in the reader. And then for the types, I'm going to say method dot method info dot get parameters dot select, which is going to bring in link, t dot parameter type dot to array. Alternatively, we could also go in and have the array of types for each method cached in the method object itself. We can do that later too as another way to shave some nanoseconds off this method. Okay, so we now have the method object, we have the arguments, so now we need to get the actual system. So to do that, I'm going to say var system object equals systems dot get by server interface ID, server interface component ID, and this will return an iSystem base. Now all I have to do is invoke the method. So I'm going to say method dot invoke, passing in system object as the first parameter for the thing to invoke it on, and passing in arguments as the second parameter. So now you see that it's a very slim system because the invocation happens right here. It's just a couple of lines of code. We extract some information out of the parameters, and we deserialize the arguments, and we invoke. And that's it. All right. So yeah, so what about onDisconnect? Well, onDisconnect is going to be invoked when the client or the transport is destroyed. So onDisconnect is simply going to say, it's just going to dispose itself. So we're going to say systems.dispose. Remember our systems object, which contains our client systems? Well, we need a way to dispose all of them so they have a chance to clean up. We also need to do our client scope .dispose so that all the things that were acquired by the IOC container get properly disposed as well. All right, what about the dispose method? Well, the dispose method is simply going to disconnect the client. So we're going to say transport.disconnect, and that's it. So yeah, so this is really going to be the bare minimum of the client context that we need to implement in order to get this stuff working. Next up, I'm going to go ahead and add our operation parameters. So I'm going to open up this this file here, and I'm going to go ahead and add the two items that we're missing, method ID and arguments. So remember, I'm in the operation parameter enumeration. So I'm going to say method ID and arguments. And that's it. All right. So we still have a couple other things we need to do. Obviously, we need to actually build up the client systems a little bit here and add the dispose. Before we do that, I want to go ahead and implement the player context. So I'm going to open up the player context. And you'll notice now he errors out. And he errors out because we've added a non-default constructor to the client context that accepts parameters. We're going to have to fill those parameters in with the player context constructor. So I'm going to go ahead and just be lazy and tell it to generate the constructor and then modify it to what I want it to do. So the actual player context is going to need to have a transport. It's not going to need a... actually, I don't know if I can get away with doing that. Oh, I can. Sweet. Okay, so it's not going to take in a component map. It's just going to take in an application and a transport. So what do we pass into the component map parameter of the base constructor? Well, that's just going to be application.playerSystemsComponentMap. All right, there's one last thing we need to do in the player context, and that is we need to tell the client to initialize itself as a player. Though I'm wondering if... Yeah. Yeah, we could do that here. So inside the constructor, I'm simply going to say transport.sendData application player init event. Just keep things simple. I mean, there would be ways to automatically select which init event to send. We could use enumeration, a dictionary of types and events, and all that fun stuff. Fact is, though, we're only going to have a handful of different context types, like a dashboard context, or a server admin context, or an automation context. Just a handful of them. So I think this will be fine. So when the player context is instantiated, he does inform the client to get set up properly based off what was in the player init event. Alright, so that pretty much should be our client context for now. Again, one of the major features that we're missing at this time is, of course, how we're going to handle return values for our method invocations, but that'll come later. So now let's go ahead and jump into our client systems. So client systems, like I said before, we are going to go ahead and remove the server context application parameter since that's now redundant. However, I'm going to go ahead and make sure it does implement iDisposable. So we'll go ahead and have a dispose method appear at the bottom here. I'm going to leave it as throw new not implemented so that we get reminded to implement that. All right, let's take off the server context application there, and so we just receive the client. Okay, so we need to implement the create, the destroy, the get by server interface ID, and the dispose. So, yeah. What I'm going to need to do here is I'm going to need to be able to reference back into our what systems that we currently have. And I think the way that I'm going to do that is I'm going to say private read-only iSystem base, and could just go ahead and have this be an array. Yeah, sure, why not? Let's have this array, and we'll call this systems. Okay, so then in our constructor, I'm going to say systems equals new iSystem base byte.max value. So we just initialize an empty array with 256 elements in it. Should be fine. Okay, so for our create method gets a little bit complicated because we need to be able to instantiate our system, and we also need to be able to generate our proxy. So the proxy is the thing that's going to intercept method invocations of the client so that they can be sent to the client to actually be executed. So yeah, let's go ahead and import manage NuGet packages. Let's go ahead and import Castle Dynamic Proxy. So I'm going to search for Castle Dynamic Proxy. It says it's obsolete. It's an old version. For the latest version, get Castle Core. All right, so let's go ahead and bring in Castle Core. And close the README. Okay, so now that we have that, we need a class that implements this iInterceptor. Because remember, the goal of what we're doing here is we need to have a object of type client system, or sorry, of type the interface type that's going to be in the base project that describes what the server can tell the client. And we need a object that intercepts those method invocations, because what we're going to be doing is we're going to be instantiating an interface. And I know that sounds weird. We're not technically instantiating an interface because you can't, but we're going to be creating a dynamic, an object at runtime that implements an interface, and we're going to intercept all calls to it and send those calls back to the client. So we do need a nested class here that implements iInterceptor. Let's go ahead and implement that first and see what that looks like. So down at the bottom, I'm going to say class client interface interceptor, and it's going to inherit or implement iInterceptor from castle.dynamicProxy namespace. And then the interceptor only has one method that you need to implement, and that is intercept. So basically intercept says what you want to have happen when the method is invoked. So I'm going to instantiate one of these interceptors per system. So I'm going to have a constructor, and the constructor is going to take in a, it's going to need a few bits of information. First of all, it's going to need byte client interface ID, a client interface component ID, and it's also going to need a transport, so an iServer transport, and it's also going to need an event writer. And I think with those three things, we should get away with this. Okay, so I'm going to go ahead and alias these all out into private fields. So we just store the client interface component ID, the transport, and the event writer. So in the intercept method, all we need to do is invoke a method on the client. So I'm going to say transport.sendData, and I'm going to say event writer.invoke method on system, passing in the client interface component ID, the method, the mapped method. Oh, this is where things get interesting, I guess. Huh. You know what I'm going to do instead? If I recall, yeah. Okay, what I'm going to do instead of taking a byte client interface component ID, I'm just going to take a mapped component. I'm going to say mapped component client interface component. Then I'm going to have that be set as a private field. This way, we'll be able to get the mapped method out of it. So I'm going to say invoke method on system, and for the client interface component ID, I'm going to pass in client interface component.id. For the mapped method, I'm going to pass in client interface component.get method by invocation dot method. And then for object array arguments, I'm going to pass in invocation dot arguments. Let me go ahead and break this out a little bit, so we can see our three parameters or three arguments we're supplying to the invoke method on system. So we're simply passing in the ID of the component, the method, mapped method of the component, and the arguments. And that's our interceptor. Okay, so how do we create something? Well, the first thing we need to do is let's see here. Oh, there's a million ways to do this. I guess the first thing we can do is just instantiate the component. And so to instantiate the component, we're going to assume that these are all mapped with our IRC container. So I'm going to say var system equals client dot client scope, which is our lifetime scope, dot resolve. And that's going to require bringing in the using autofac. And we're going to pass in a generic parameter of t concrete type. Then I'm also going to go ahead and add a generic type constraint to the top of this. I'm going to say where t concrete type implements iSystem base. Now that's important because I need to be able to statically refer to the members of iSystem base, and by adding this generic type constraint I can do that, because we know that's whatever's returned by resolve is going to be of that type. So now if I can do system dot, I can get information about the client system interface type and the server system interface type. Okay, so next up, let's go ahead and get the two components, the two mapped components, so we can get some more information about the system. So I'm going to say var server component equals client dot systems component map dot get component passing in system.serverSystemInterfaceType, and then var client component equals client systems component map get component system.client. So now we have information about both what the client interface is and what the server interface is, which is really important because that's how we instantiate our dynamic proxy, and it's also how we're going to add our system to the array that we created. It's also how we're going to create our interceptor. So now what needs to be done is we need to cast this system object into our iInternal system so that we can invoke the init method on it. So remember, that's the so the init method is going to be how we pass in the client context and the object proxy. So what I'm going to do here is, I guess before we do that, we first kind of have to go ahead and generate the proxy. So let's go ahead and do that. So in order to go ahead and create our client proxy, we do need to have something called a proxy generator. Now the proxy generator is designed to be a kind of a singleton. So what I'm going to do is I'm actually going to go ahead and wrap the proxy generator in a static class up in the base project. And that's because the proxy generator is going to also be necessary to reference from the client as well as the server. So I'm going to go to References, Manage NuGet Packages, and I'm going to bring in Castle. So I'm going to bring in castle.core. And now that we're referencing Castle Core from the base project, I can open up the infrastructure namespace. I'm going to create a new class called Component Proxy Generator. And the Component Proxy Generator class will be static. It'll have one static field, so it'll have a private static proxy generator, which will import castle.dynamicProxy proxy generator. Then he's going to have a method, public static object, create interface proxy with target, which mimics the method that we're going to be invoking on the proxy generator. I'm going to pass in a type interface type and a params iInterceptor array of interceptors. This method is simply going to say if proxy generator equals null, proxy generator equals new proxy generator. Then I'm simply going to say return proxy generator dot create interface proxy with target, passing in the interface type and the interceptors. It's really important to make this proxy generator class a singleton so that you don't have a bunch of dynamic assemblies being added whenever it creates your type. So all of the types that it generates for you are cached and don't need to be regenerated. So that's really important to do. And I decided to go ahead and kind of abstract it just a tad, even though I'm not really abstracting because we depend on the iInterceptor namespace. I could just make this a public static proxy generator. I don't know why. It just seems kind of gross to me. I don't know. Either way, coming back into our client systems, we can now generate our proxy. So I'm going to say var client proxy inside of our client systems equals component proxy generator dot create interface proxy with target. The interface type is going to be client component, or we can just do system dot client system interface type. And so what do we pass into the interceptors? Well, remember the interceptor class we made down here. So I can simply say new client interface interceptor. Let me go ahead and break this out into multiple lines so you guys can see what's going on here. So in the arguments I'm passing in a mapped component, the client interface component, which is going to be client component up at the top there. We need a server transport, which is going to be client.transport. And we need an event writer, which is going to be client.application.events. That's really all the information the client proxy needs. Now that we've done that, we can initialize our server. However, I'm not going to initialize the server component just yet, because I first want to make the client aware that a new system was created, because it's very possible that within the server component initialization, he's going to invoke methods that need to be passed on to the client. If the client doesn't know that a system was made, then it's not going to have it instantiated and bad things are going to happen. So the first thing we need to do is tell the client that a system was added. To do that, we simply do client.transport.sendData, and then pass in client.application.events.addSystem. And we need to pass in a registered system into this method. So to get a registered system, we can pass in client application.systemTypeRegistry.get system from concrete type, type of T concrete type. Alright, so this is getting a little wild. What I'm going to do is I'm going to break each one of these out into local variables so you guys can see what's going on. So I'm going to go ahead and extract this, and I'm going to say this is a registered system. And then this is our add system event. So first we get the registered system from the system type registry, then we create the add system event with the application events add system, then we send that data to the client. So now the client knows that there's a new system being created and is ready to receive additional requests. Now we can initialize the actual system. Actually, I want to go ahead and I want to do that last. I really do. So what I'm going to do is I'm going to go ahead and add it to our systems first. I'm going to say _systems at server component .id equals system. Then I'm going to do something weird. I'm going to say cast to internal system .init, passing in our client and our client proxy. Last thing I'm going to do is return system. So yeah, again, this is all frameworky type code, and it's kind of annoying having to refer back to this application. But again, you can think of the application class as what you would traditionally use singletons for, basically. But yeah. The only thing I need to do now is I need to ensure that we can't add systems multiple times. So before we generate the client proxy, after we've established the server and client components, I'm going to say if systems at server component.id does not equal null, throw new invalid operation exception, cannot add blank system twice, and I'm going to pass in type of T concrete type.name. How about full name, just in case you have two systems with two names, similar names that are different namespaces. All right, so that's our create method. Let's work on our destroy method. Well, we also have the get method, which is going to require that we have a dictionary. So in addition to our, well, do we? I mean, what does the system type registry have? It has these registered systems. Yeah, I'm going to go ahead and just speed this up a little bit. So inside of the client systems, I'm going to add a new, a private read-only dictionary of type and iSystem base. So we're going to be storing our system bases in two types of collections, in an array and in a dictionary. And I'll call this concrete types to systems. Then I'll go ahead and make sure to instantiate this in my constructor. Then what I'm going to do is down here on our create method, after we assign the system to our systems array, I'm going to say concrete types to systems.add, passing in type of T concrete type and system. The reason this is important is because on my get method, I'm going to have to retrieve a system by concrete type, and it'll be faster to do it through this dictionary lookup than it would be through scanning the array, which even then we would have to try to do another dictionary lookup to get the ID anyway. All right, so the destroy method is going to be pretty straightforward. We simply need to do var system, well, so we have our concrete type, so I can go ahead and say, all right, let's go ahead and first get our registered system. Or let me first just extract the system. I know I keep on changing my mind. I'm going to say iSystem base system. I'm going to say if not concrete types to systems, try get value, type of tConcrete type out system, throw new invalid operation exception, blank, no, system blank was not found, passing in type of tConcrete type full name. Now that we've done that, we can go ahead and extract the ID, because we need to have the ID of the server interface to remove it from our array. So I'm going to say var server component equals client dot systems component map dot get component system dot server system interface type. Then let's go ahead and remove it from stuff. Well, let's not remove it from stuff yet. Let's tell it to dispose itself. So I'm going to say system.dispose. Now you'll notice that dispose has not been implemented yet. What I'm going to do is I'm going to have iSystem base implement iDisposable, or rather inherit from iDisposable. So I'm going to say system.dispose. That line won't compile just yet, but it will here shortly. Then I'm going to say systems at server component.id equals null. Then I'm going to say concrete types to systems remove type of tConcrete type. That's it. Next up, on the get method, I am simply going to, this is going to be pretty straightforward, I'm going to say return cast to tConcrete type, concrete types to systems, type of tConcrete type. So I'm just going to delegate all the responsibility of this onto the dictionary. Now, fortunately, because I'm using the bracket and not or the indexer and not the try get, it will throw an exception if the system wasn't found, which is good because that indicates a bug in our software. All right, next up is the, destroy. I completely forgot to actually tell the client that the system was destroyed. Well, that won't be good. What I'm going to do here is I'm going to tell the client to destroy the system after we tell the system to dispose itself. That's because when the system disposes itself, it might want to send some more data to the client, and so we don't want to tell the client just yet to destroy his own local object. So I'm going to say client.transport.sendData, client.transport. We're going to need so I'm going to say var. What did we write in our event writer for our remove? We need a registered system. So we do need to go ahead and get a registered system. And we get the registered system by saying var registered system equals client application system type registry, get system from concrete type, type of tConcrete type. Now that we have the registered system, we're going to say client transport send data, client application events dot remove system, passing in registered system. And so this will actually send the packet to tell the client to dispose of the system object. All right, so that's destroy. Let's move on to get by server interface ID, because this is going to be really easy. Return systems at server interface ID. That's it. All right, now we have dispose. Now with dispose, I'm not actually going to worry about disposing. Well, I do need to dispose the systems, but I don't need to send any messages to the client because the client's already been told that he's been disconnected or will be disconnected, or he will be told that he's been disconnected after all this code has been executed. So I don't need to worry about removing the systems or cleaning anything up. I just need to tell the systems themselves to dispose themselves. So I'm going to say for each var system in concrete types to system, system.value.dispose. And that's really it. I'm not going to worry about cleaning up anything else because it's kind of irrelevant. So yeah, that is our client systems implementation. So now let's go ahead and add, have our system base inherit from dispose. So I'm going to go into system base and I'm going to make it inherit from my disposable. And that's it. Of course, this is going to add some errors. The reason is our test system base needs to implement a dispose method. So this test system base comes out of our system type registry tests in our test assembly. So because I just added the interface inheritance of iDisposable to the iSystem base, we're going to make sure that we implement dispose on all of our classes that implement that interface. So I'm going to say public void dispose, and I'm just going to leave it empty. We'll also get another error on our client system base. So if you remember our client system base tick 3, we'll also need to implement a dispose method. But what I'm going to do here is I'm actually going to go ahead and, well, I guess we can go ahead and actually properly implement the client system base. It's pretty straightforward, actually, because our client systems is implemented. There's really nothing more we need to do here. It manages systems and it tells the client when they are destroyed and when they're added. So now we can go to our client system base tick 3, and I'm going to do something interesting here. I'm going to go ahead and make this an abstract class, first of all. And the reason I'm making an abstract class is because I'm going to implement dispose as an abstract method. So I'm going to say public abstract void dispose, which then allows us to implement dispose on our... Actually, I kind of want it to be virtual. Never mind. I want it to be virtual because not every component is, or every system is going to need dispose logic, so I'm just going to make it virtual. Alright, so that's our stuff right there. Hopefully that's making sense. Really let's go ahead and implement our init. What I'm going to do is I'm going to add a protected virtual void awake method to our client system base tick 3, and it's going to be empty. The init method really couldn't be simpler. I'm simply going to say context equals cast to t context type client, and then proxy equals cast to t client interface proxy, and then I'm going to simply invoke awake. That's it. So then when we do something like we add a new character select screen system, for example, we'll have a opportunity to send information to the client, like telling him what characters are available to select and all that fun stuff. But either way, that should just about do it. We have our client context, he's all working, client system base tick 3, we have our client systems. And really the last thing that we need to do is implement our event writer, and then actually go ahead and work on our peer and get this moved over into, or get an implementation of the system working in our server master and deal with our component configuration and stuff like that. Alright guys, I think we'll see you in the next video.